Hello students, today we will be talking about the structure, processing and storage of pulses and legumes and the way they are cooked in our food. The term legume refers to the plants whose fruit is enclosed in a pod. Legumes represent a vast family of plants including more than 600 genera and more than 13,000 species. Pulses are part of legume family, but the term pulse refers only to the dried seed. Dried peas, edible beans, lentils and chickpeas are the most common varieties of pulses. The term pulse, as used by the United Nations Food and Agricultural Organization, is reserved for the crop harvested slowly for the dry seed. This excludes green beans and green peas, which are considered as vegetable crops. Also excluded are seeds that are mainly grown for oil extraction and seeds which are used exclusively for sowing forage. However, in common usage, these distinctions are not always clearly made, and many of the varieties used for dried pulses are also used for green vegetables with their beans in pods while young. The word pulse comes from the Latin word pulse, which means the seeds that can be made into a thick soup. Well-known dried legumes include chickpeas, beans, red kidney beans and black-eyed beans, etc. Legumes come in a variety of shapes and sizes and colors and can be consumed in many forms, including split, ground into flour or dried canned, cooked or frozen whole legumes. Structure of pulses. Pulses have a similar structure but differ in color, shape, size and thickness of the seed coat. Mature seeds have three major components: the seed coats, cotyledons and the embryo. The seed coat or hull accounts for 7 to 15% of the whole seed mass. Cotyledons are about 85% of the seed mass and the embryo constitutes of remaining 1 to 4%. The external structure of the seed are testa, hilum and ref. The testa is the uppermost part of the seed and covers almost all the seed surface, and the hilum is an oval scar on the seed where the seed was attached to the stalk. The micropyle is a small opening of the seed coat in the hilum. The ref is the ridge on the side of the hilum opposite to micropyle. When the seed coat is removed from grain, the remaining part of the embryonic structure consists of two cotyledons and a short axis above and below of them. The two cotyledons are not physically attached to each other, except that the axis and a weak protection provides the seed coat. Thus, the seed is unusually vulnerable to breakage. The outermost layer of the seed coat is the cuticle and it can be smooth or rough. Both micropyle and hilum have been related to the permeability of the testa and to water absorption. The seeds have two large highly nutritious cotyledons, and the cotyledons are the first two leaves of the embryo and become so large because they absorb all the endosperm available in the seed. The endosperm is a triploid tissue that results from fertilization, and its role is to feed the very young plant at the time of germination. The composition of pulses and legumes. Pulses give 340 kilocalories per 100 grams, which is almost similar to the cereal calorie value. And protein. In a vegetarian diet, pulses are important sources of protein. They give about 20 to 25% of protein, and the proteins of pulses are of low quality since they are deficient in methionine and tryptophan. Pulses are rich in lysine, the most effective combination to achieve maximum supplementary effect in 5 parts of cereal proteins and 1 part of pulse protein. In terms of grains, 8 parts of cereals and 1 parts of pulses. So, this combination gives a protein quality equivalent to animal protein as they contain all the essential amino acids. Carbohydrates. Pulses contain 55 to 60% of starch. Soluble sugars, fiber and unavailable carbohydrates are also present. Lipids. Pulses contain 1.5% lipids on moisture free basis. They contain high amounts of polyunsaturated fatty acids. Along with cereals, they meet the requirements of essential fatty acids for an adult. Apart from linoleic acid, the most legume seed oil contain high proportion of linolenic acid. They undergo oxidative rancidity during storage, resulting in loss of protein solubility, off flavor development and loss of nutritive quality. Oleic, stearic and palmitic acids are also present. Coming to minerals, pulses are important sources of calcium, magnesium, zinc, iron, potassium and phosphorus. 80% of phosphorus is present as phytate phosphorus. Phytin complexes with protein and minerals and render them biologically unavailable to human beings and animals. Processing such as cooking, soaking, germination and fermentation can reduce or eliminate appreciable amounts of phytin. Vitamins. Legume seeds are excellent sources of B complex vitamins, particularly thiamine, folic acid and pantothenic acid. Like cereals, they do not contain any vitamin A or C, but germinated legumes develop some vitamin C. Fiber in pulses is not generally absorbed by the body and thus increases the stool volume and transit. The fiber also serves to bind toxins and cholesterol in the gut so that these substances can be removed from the body. This improves heart health and lowers blood cholesterol. Coming to the digestibility of pulses, among legumes, chickpea protein has high digestibility. Other legumes including lentils and phaseolus varieties have low digestibility. Factors that reduce the digestibility of pulses protein are: pulse proteins have high molecular weight and compact molecules that reduce the digestibility. Some proteins are complexed with carbohydrates and influence digestibility. Some proteins are complexed with phytin and decrease the digestibility. So, digestibility in pulses range from 50 to 62%. Anti-nutritional factors are also present in the uncooked legume seeds, which contain natural toxic substances. Some are trypsin inhibitors. Trypsin inhibitors are proteins that inhibit the activity of trypsin in the gut and interfere the digestibility of dietary proteins and reduce their utilization. They are generally heat labile and moist heat treatment like pressure cooking destroys them. Autoclaving at 120 degrees centigrade for 15 to 30 minutes will inactivate all trypsin inhibitors. So, these inhibitors prevent degradation of storage proteins during seed maturation. Lathrinogens are the other anti-nutrients which are present in kesari dal, and this dal is grown in Madhya Pradesh. It was observed that during the drought condition, only this dal is grown and used as staple food. So, toxin can be removed by steeping or parboiling. When this dal is consumed over a long time, paralysis of lower limbs occur in males. This is known as lathyrism. So, it is reported when intake of kesari dal is restricted to 30% of total calorie intake, no adverse effects are observed. Therefore, it is important to ensure that the intake of this dal must be restricted to a maximum of 30% of total calorie intake. Favism is a disease characterized by hemolytic anemia that occurs when individuals who are deficient in glucose 6-phosphate dehydrogenase consume faba beans or broad beans. 3 compounds play a causative role in the disease. 2 of these are glycosides and the third one is an amino acid derivative. Germinating and boiling reduce these toxic substances. Hemagglutinin. These are proteins in nature and sometimes referred to as phytoagglutinins or lectins. Hemagglutinin reduce the food intake, resulting in poor growth. Hemagglutinin are isolated from soybean, field bean, white bean, double bean and horse gram. Hemagglutinin are heat labile. Goitrogens. These are substances which interfere with iodine uptake by the thyroid gland. So, excessive intake of these foods in face of marginal intake of iodine from foods and water may lead to precipitation of goiter. These are present in soybean, groundnuts and lentils. Tannins. Tannins are condensed polyphenolic compounds. They are present in high amounts in seed coat of most legumes. These tannins bind with iron irreversibly and interface with iron absorption. And tannins also bind proteins to reduce their availability. So, removal of seed coat of legumes reduces the tannin content, and removal of husk lowers the tannin content and thus improves the appearance, texture, cooking quality, palatability, digestibility of the grain and also the bioavailability of nutrients. Processing of pulses and legumes. Milling and decortication. Legumes are generally milled to remove the outer husk either by wet or dry process. The dal obtained by dry method is hemispherical in nature and softens rapidly on cooking and gives good flavor. Dal prepared by wet method is usually that has a small depression in the center due to shrinkage and softens slowly during cooking. Legumes are consumed as whole or dehusked ones. Milling yield can be increased by lower seed coat percentage, regular shaped grain variety and having loose husked varieties. Heating the seed before dehulling. Normally the percentage of yield is 82% during milling. The advantages are the protein digestibility is increased, net protein utilization is higher and the removal of hull facilitates the reduction of fiber. So, nutrient availability is increased. Seed coat accounts to 80 to 90% of total seed polyphenols. So, dehusking removes anti-nutritional factors and this improves appearance, texture, cooking quality and palatability, and the keeping quality is also improved. So, in dehusking, germ may be removed with skin and may result in loss of thiamine. Soaking. Many pulses, particularly whole grams which have hard outer covering, need soaking prior to cooking. During soaking, water enters through the hilum or scar where the bean is attached to pod. From there it seeps around the periphery of the bean and causes seed coat to wrinkle. Whole pulses soaked in cold water overnight or hot water for 4 to 5 hours. Soaking makes the pulse tender and hastens the process of cooking. Soaking in salt solution is preferred to loosen the seed coat and enhance the water absorption. Addition of soda reduces cooking time significantly by 1/3, but also decreases the thiamine content from the dal. Germination. Whole grams are soaked overnight and should be drained away and seeds are tied in loosely woven cloth and hung. Water should be sprinkled twice or thrice a day. So, in a day or two germination takes place. Moisture and warmth are essential for germination. The advantages of germination are nutritive value is improved. During sprouting, dormant enzymes get activated and digestibility and availability of nutrients is improved. Starch and proteins are converted into simpler substances as germination proceeds. The ratio of essential amino acid changes, providing more of essential amino acids. Sprouting reduces the trypsin inhibiting factors due to release of enzymes, and germinated seeds have more of maltase. So, during sprouting the cell walls are broken down and availability of nutrients increase, and the minerals like calcium, zinc, iron are released from bound form. So, phytic acid is reduced, so the availability of proteins and minerals is increased. Riboflavin, niacin, folic acid, choline and biotin are increased. Vitamin C is synthesized during germination and can be substituted for fruits. So, to increase the vitamin C is around 7 to 20 milligrams per 100 grams of pulses. After 30 hours of germination, the vitamin C content is maximum, and sprouting also decreases the cooking time, and dehusking is easier when grains are sprouted and dried. Germination decreases mucus inducing property of legumes. Thickening power of starch is reduced due to conversion of starch to sugars. Germination metabolizes oligosaccharides and hence do not produce gas or flatulence. Germination improves taste and texture, and without much cooking also sprouts like green gram can be consumed, and germinated pulses add a variety to diet. The next process is fermentation. This process increases the digestibility since microbial enzymes break down the legume protein and enhance the cooking process. It also improves the palatability and nutritive value. Toxic substances of pulses can be eliminated by fermentation. In idli making, fermentation process improves the availability of essential amino acids and thus nutritive quality of the protein is improved. So, dosa and idli are the best examples of fermented foods. Parching and puffing. Legumes such as Bengal gram and peas are parched to give highly acceptable products. The traditional Indian household practice for roasting and parching pulses involves initially sprinkling the grain with a little water, and the pulse is mixed with preheated sand in a frying pan kept on open fire and maintained at a temperature from 200 to 250 degrees centigrade depending upon the species of pulse for 2 to 3 minutes. Puffed pulse grains are prepared in the country and in the manner similar to that used for roasting. So, puffing, the seeds are soaked in water mixed with sand that has been heated to 250 degrees centigrade and then heated for short time. So, the more common legumes prepared in this manner are chickpeas and field peas. Parched Bengal gram has been used successfully in treatment of protein calorie malnutrition in children. Now, different forms of pulses. Pulses are used in different forms such as whole legumes, decuticled split legumes with skin and without skin, germinated or fermented pulses, flour of pulses and parched pulses like Bengal gram and peas. Soy products available in the market and their use. Soybean is a pulse which is high in protein content and is considered as a substitute for meat protein which is expensive. Soybean can be processed to obtain the following food products. One is soy flour. Soybean is slightly roasted and ground to yield flour. Oil is sometimes removed from the bean to give defatted soy flour which has high keeping quality. Soy flour is used in combination with wheat flour in the preparation of chapatis. It can also be incorporated in the batter and used in the preparation of bhaji, vada and pakoda. Soya milk. The milk is prepared by grinding the soaked beans with water and then passed through a mill in a stream of water. The emulsion that is obtained is filtered and transferred to a boiler mixed with vitaminized margarine to which sugar, salt, calcium and malt are added. This mixture is cooked for 20 minutes, emulsified and then dried. The white emulsion is expressed from soybean has the appearance of milk. Soybean curd. Tofu or soybean curd is prepared from soy milk. The curd is precipitated from milk emulsion by adding calcium sulfate. It is allowed to settle and this is separated and washed and dried. It is a soft delicate structure which resembles paneer and can be used in the form of paneer in various preparations. Textured vegetable protein. The textured vegetable protein is prepared by using defatted soy flour from which most of the oil and carbohydrates are removed. The flour contains 70% protein and is made into dough to which color, flavor are added. It is at times fortified with vitamins, and the dough is extruded through an equipment at high temperature and pressure, and the product is expanded by sudden release of pressure. The extruded granules are marketed as texturized vegetable protein. It is rehydrated with water before use in the preparation of vegetarian and non-vegetarian dishes. It resembles the meat fibers. Soy protein isolates are protein granules isolated by processing, and they are fortified with vitamins and minerals and used as a complementary food. Apart from these fermented soy products, soy sauce, soy paste are used in the preparation of Chinese dishes. Now, storage of pulses and legumes. Pulses can remain in edible condition for several years if properly stored. Pulses are more difficult to store than cereals and suffer much great damage by insects and microorganisms. This not only results in quantitative loss, but also qualitative reduction in nutritive value because of loss of vitamins and deterioration of protein quality. The milling losses in insect damaged grains are even higher than breakage or powdering in the grains. Most important factors of grain deterioration are interaction of temperature, humidity, moisture, and the main determining factors are these. The higher these factors, the more rapidly grain deteriorates. So, harvesting at 14% moisture content captures grain quality and reduces mechanical damage to the seed, but requires careful management to avoid deterioration during storage. Grain Trade Australia sets a maximum moisture limit of 14% for most pulses, but 12% is more safe. As a general rule of thumb, higher the moisture, the lower the temperature required to maintain seed quality. Grain pods and grains increase the risk of mold developing during storage. Aeration cooling will help prevent mold hotspots by creating uniform conditions throughout the grain bulk. Pulses exposed to weathering before harvest deteriorate more quickly in storage. Chickpeas stored for medium to long term continue to age and lose quality. Aeration cooling prevents moisture migration, maintains seed viability, reduces moisture growth, lengthens insects reproduction cycles, slows seed coat darkening and quality loss. Storage methods. There are two methods of storage. In bags can be stored either in open air or in warehouses. In bulk grain is stored in bins or silos of various capacities. The traditional storage systems used by small farmers are fabricated with the use of artisan construction techniques and local materials. So, the pulse cookery, the cookery quality of pulse is the function of cooking time, that is the time of boiling during which they attain desirable softness. In addition to cooking quality, it is also the function of an increased volume after cooking, high dispersibility of solids into cooking media and improved texture. Pulse foods which are too hard, sticky or slimy in texture are unattractive. So, cooking time influences the nutritive value and overall utilization of pulse. Effect of cooking. Anti-nutritional factors that can be toxic if large amounts are consumed. Trypsin inhibitors and hemagglutinins disappear at 90 degrees centigrade. However, polyphenolic compounds, although decreasing with time, are still found in cooked material. The protein quality is improved by moist heat and available lysine is decreased in roasted pulses as compared to boiled and pressure cooked ones. Heat treatment causes loss of methionine, which is an important amino acid of legume. Cooking has little effect on calcium, magnesium and total iron content, and loss of thiamine may occur due to heat that is applied. Sodium metabisulfite is found to be effective in maintaining color of lentils. Other seeds acquire darker color during processing. Factors affecting pulse cookery: soaking in water hastens the cooking, and soaking in boiling water reduces cooking time as the enzyme phytase present in legume is inactivated. Hard water prolongs the cooking time of dried pulses because of the presence of calcium and magnesium ions in hard water. Addition of cooking soda will hasten cooking but cause loss to thiamine. Addition of acidic component such as tomato, tamarind juice will prolong the time of cooking pulses. Cooking time is considerably reduced when pulses are cooked by the use of steam under pressure. So, role of pulses in cookery: pulses are rich in protein and B vitamins and improve the quality of cereal protein. Pulses give due to high protein and fiber. Pulses improve flavor and consistency of dal. They contribute to fermentation in preparation of idli and dosa. They are used in snacks like sundal, bhaji, pani puri and bhel puri. They are used as salads. They are used in desserts like payasam and sweets like laddu and Mysore pak, and they are used as thickening agent and prevent curdling like Bengal gram flour in kadhi. They are used as stuffing agent in purna, and parched pulses are used in making chutneys and chutney powders, and they are used as a part of seasoning in curries. So, this is how the pulses have a very good nutritive value, and they should be stored very carefully and preserved, and the cooking methods that are used should remove the anti-nutritional factors so that we can get the highest nutritive value from the pulses.